represent our FCS activity. So our activity is digital simulation, lag lead and capacitor design. So next up, my group teammates Manish Kote, Pradeep Shinde and me. So we next are introduction. So here we discuss about the digital simulation of lag lead capacitor design. So lag and lead capacitor are possible in control system, enhance the system performance in the term of stability, and the response and steady state error. Digital simulation involves in modeling capacitor using the MATLAB simulations and simulating absorb of effects of system. Lag capacitor improves the steady state, accuracy and lead capacitor boost the final response. This is simulation of the provide fundamental understanding and capacitor of design help even if the stability of the various practicals and application of the control is in easy. So next are circuit diagram. So first is lead capacitor circuit diagram. So first is there are some models. First is step input. Second is some transfer function of the connected to the scope. So step input and then next are lag capacitor circuit diagram. So there are ramp between steps. So next simulation explain by Pradeep Shinde.
My name is Pradeep Shinde. So we will going to make lag compensator design simulation and lead compensator design simulation. So we will firstly make the lag compensator design simulation. So we will add all required blocks for lag compensator design simulation. So we add step input, then summation block, then transfer function 1. Then we change the transfer of numerical coefficient of transfer function and denominator coefficient of transfer function. Then we add to the scope and we add the two support for this scope. Then we simply join the step input to the summation block of plus sign. Then join the transfer function to the port on the scope. Then we will copy it and paste it. Then we will add. Then we will change the numerator coefficient of transfer function to and denominator coefficient of transfer function to.
Yeah, for install purpose.
Change the values of numerator coefficient and denominator coefficient of both transfer function. Then run the simulation. Here is the output graph of lag compensator design simulation. We will make the two simulations for lag compensator design, which is first one is based on step input and other one is based on ramp input. Simply we will replace the ramp input. Here is the output graph of the ramp input. Okay, apply. To make the digital simulation of lead compensator, simply this simulation is similar to lag compensator design. We simply change the transfer function of change the numerator coefficient and denominator coefficient of both transfer function, which is transfer function 1 and transfer function 2. So we change the values of both transfer function. And also we will change here is our output graph of the step input of here is the output graph for ramp input for lead compensator design. Thank you.
See output of lag compensator step input graph, and this is the lead compensator lag ramp input model graph. Conclusion: in the project, the design and implementation of digital lag and lead compensator were successfully carried out using MATLAB through simulation and analysis. The distinct role of lag and lead compensator in enhance control system performance were clearly The lead compensator significantly improved the system's transient response by increasing the phase margin, reducing overshoot and speeding up the rise and settle time. This made the system more responsive and stable in dynamic condition. While each compensator has its strength, they also prevent trades-offs. The lead compensator may increase sensitivity to high frequency noise. Thank you.